Welcome to Season 2, Episode 8 of Tech Talk Thursday. My guest this week is Mark Thompson from Nanodynamics, manufacturers of the infamous Dragonfly all-in-one additive printer that can manufacture up to 60 layers PCBs to a tolerance of 4 mil track in space in one box. The latest version of Dragonfly, the LDM2, is now available, and our guest is here to tell us about it. Let's meet Mark Thompson. Welcome, Mark. Thank you for joining me today. The Dragonfly has been around for quite some time. It basically was a very innovative product when it came out for making prototype PCBs, literally using an additive process. What has happened to it in recent years? What have you done to the product in recent years to upgrade it?
Well, thank you, Trevor, for inviting me and having this opportunity to speak with you. So thank you for that. Dragonfly has matured a bit, and we're now into generation 2. We're in what's called the LDM, so that stands for Lights Out Digital Manufacturing. And really what the latest version allows the value to the operator is having an automatic maintaining routine. So during the print, there's no requirement for the operator to be involved for that. The system maintains cleaning itself and recovery. So basically, you can turn off the lights, go home, come back in the morning or come back on the weekend and have the board completed for you.
So is it using larger tanks of ink, etc., so it doesn't need to be replenished manually?
So great question. So there are reservoirs that are dedicated, so you just continue to add materials to the reservoirs as needed. So there isn't the need to worry about depleting them during an overnight run, for instance.
Okay. So, initially when it was sold to the defense industry and for NPI use. What other markets is it proving good for at the moment?
So you're correct in the aerospace and defense markets. That still is a predominant stronghold today, but in the academic space, both in the research institute and some of the government laboratories around the world are quite interested in taking what we know that the Dragonfly can produce today, according to design rules, and then go ahead and push the envelope envelope on what the system's capable of doing. And so in doing that, they're able to produce what we would call high performance electronic devices outside of simple PCBs or outside of PCBs, and has really had a strong input into the sensor industry and the medical space also.
Right. That's interesting. So for those of us that are not that familiar with it, tell us, can you show us a little bit about how it works?
So this slide on how it works. So this is the Dragonfly LDM system that we're looking at on the left-hand side. And on the right-hand side is it basically shows how the materials work. So what's unique to us in the additive space is that we put down both materials simultaneously. So we precision jet both our conductive ink, which happens to be a silver nanoparticle, and our photopolymer, which happens to be our dielectric. We put both of them down simultaneously and activate both of them on the fly. So as obviously we build up from the bottom up, micron by micron, but that just ensures that we're able to maintain good electrical properties throughout the entire stack up.
Right. Okay. So I mean, obviously the metal part, you're jetting metals essentially when you're putting down the conductors. How difficult has that been? And is that what sort of work did you have to do to develop ahead to be able to make that happen?
Yeah, so that's a great question. So we have a real strong materials research group, and that is our intellectual property. So there are patents associated with both materials as well as the manufacturing of these materials. So that's something that's unique to the Dragonfly in this specific formulation. And so the sintering process that happens on the fly using near infrared as well as the curing process for the dielectric are fully complementary and fully additive. And so we're able to do both materials, as I had mentioned, real time and on the fly.
Right. Now, I believe this process allows you to do a few things that you couldn't do in a standard board layout process. Can you illustrate what you're talking about there?
Great question again. And so this just happens to be a comparison of what a conventional fabrication device, a truly analog or a subtractive process on the right-hand side, on what a stack up would look like in a conventional fabrication of a printed circuit board. Now on the left-hand side is where we are in a truly additive manufacturing electronics. So we end up with a monolithic structure, even though maybe electrically they're the equivalent diagrams, they're the equivalent functions. We're able to create structures inside of this that allow us to build curved devices or diagonal, blind and buried vias, even embedded capacitors and inductors that the conventional capabilities just do not allow.
Right. Yeah. As you say, the conventional capabilities, you have to work in a very planar, constricted process. You can go in at diagonal vias and all sorts of buried capacitors, different things you can put in there. That's really interesting. Now, you mentioned earlier just a little bit about some of the other applications you're doing. You're doing more than just straight printed. What other types of interconnection devices and sensors are you producing?
Yeah, so I've got a couple of applications that we've worked in here, and so clearly in the vertical space, being able to shrink the overall board utilization and being able to optimize that. On the left-hand side, we've got packaging where we can integrate 3 separate integrated circuits within a package, form factors along the top, since we're able to create basically the entire envelope that you need to use to design something. It no longer is required to be square or rectangular or cut out. We can maintain cavities inside of this. And then in the central region over here, we're looking at both our embedded capacitors, so we free up real estate on top of the board. And we also have on the far right-hand side, the edge contact, so we can gain access to a lot more nodes within the board that weren't possible before either. And so these are just a couple of things that we do with the Dragonfly capability.
Big data, artificial intelligence, and smart factory solutions are here now. Automated optical inspection is critical in a smart factory environment. Leading the way to Industry 4.0, Mertech invites you to the smart factory of the future.
Now, you mentioned earlier in the discussion, or at the beginning of the discussion, Mark, that this new model is called the LDM, the lights out model. What do you mean by what do you mean exactly by lights out, and how does that work?
So what that predominantly means is that you as an operator have this system in-house in your lab. You load in a file ready to print, you push print, and say it's a Friday night and you're headed home for the weekend or whatever that is. Lights go out in the lab, but the system continues to print uninterrupted 24 hours a day until it's completed its job. So printing time may take just a couple of hours depending on the complexity of something. Highly complex boards may take a day or two to even print, but the point of the lights out part of this is that the system will continue to print until it's completed the job without operator intervention.
Okay. And so, beyond the fact that you're able to produce your own boards on site, what are the key benefits for using this equipment?
So rapid prototyping is really the space that we play in the strongest, right? So these are going to be the value add propositions for a customer that has a design, first order design, that needs to validate the first article and being able to do it quickly. A lot of times, especially in complicated designs, they may go from design and go through a conventional means, and it may take weeks, potentially even longer than that, to get a board back to find that A, it doesn't work, or B, that there's iterative work that has to be done. And so the insertion point inside of a program could be at risk and missing that completely. With us, since we're additive and we can basically turn around a print in a matter of hours or days, we can give you that agile, iterative design capability. So you can go from design to first order verification, and then even iterative designs until you can get to the outcome that you really need to insert to manufacturing or program.
So is it using standard PCB design software, or are there specific design rules that you have to follow?
That's a great question. So our system uses an interface called Switch. That's basically a proprietary interface for our printer, but we read in Gerber files in the case, which is kind of a standard ECAD file format coming for PCB board design. But we also can read in three-dimensional design files as STLs out of SolidWorks, for instance. And so we can read those into the systems directly. And then the printer formulates that into many thousands of layers to define how much ink it has to accomplish in each pass. And you basically push print and walk away, and then it becomes completed at that point.
Right. Okay. Interesting. So I believe one of the other benefits of this system is it occupies quite a small footprint compared to, say, a conventional PCB fab. Can you talk to us a little bit about that?
Yeah, so it is a fab in a box, right? That's so it is a small footprint. You can kind of see the one behind me there, and so it's an environmentally friendly and office friendly printer. So typically a couple size of a refrigerator side by side kind of a thing, but it doesn't take a lot of special facilities to maintain this thing, and it literally is office friendly. So there's not any special considerations for fume hoods or noxious fumes. It's all self-contained.
Yeah, I mean, that was going to be my next question. I mean, how environmentally friendly is it to both to operate and to be around?
Great question again. So the materials themselves are all contained. So the silver nanoparticle as well as the photopolymer for the dielectric. Once we go through the curing process, they're solids. That's kind of what I'm holding in my hand right here. They're solid, just like a circuit board would be. There's no more hazardous concern at this point, and there isn't actually hazardous concern in the material themselves. You know, they are solvent-based because they are jetted by the print head. But once everything's evaporated out and cured, they're robust, and there's no concerns for the materials.
Right. And how do you do the curing process? I mean, is it a UV cure? What kind of cure is it that you use?
Great question again. So on the dielectric side of things, they are in fact UV cured. So the photopolymer, there's a lamp station for UV on one end of the stage drive. There's a near infrared lamp station on the other side of the stage drive. And so this stage goes back and forth, and you can kind of see it real time happening behind me. And it moves under the lamp for UV to cure the dielectric, and it moves under the near infrared lamp to cure and center the metallization for the silver conductive ink. Right. That just happens simultaneously throughout the entire print process.
So it's a combination of thermal and UV cure. That's
absolutely
interesting.
There is a stage. The stage is at elevated temperature just to drive out solvents and further cure at temperature, but that's, it's a very robust process, pretty quick, works out quite nice, and delivers some very unique capabilities that you might not be able to do otherwise.
I'm sure you're coming up with novel ideas all the time, but
yeah, well, everybody wants something to flex. We're not necessarily pushing flex circuits, but certainly it has the ability to be conformal.
Yeah, well, that's useful too. Yeah, that's great. So it's definitely a very unique product, Mark. And tell me, where do you think it's going to go? What's next for it? Where do you we've obviously got a development path.
We do.
Where do you see this being in 5 years?
Yeah, so we'll be working more towards the production-oriented type of environment. Right now we're doing rapid prototyping space, so low-level fabrication of something, whether it's a single unit, tens of units, maybe even up to thousands, depending on size. The existing system can do that. But as we develop new materials, of course, everybody wants to build something that they can have qualified for flight or qualified for transportation and something like that. So we're moving towards that in our material space, just to have a more robust complementary of materials available to use in industry.
Right. Great. Well, it's certainly interesting. So we look forward to hearing more about it as we go forward. But for now, Mark, I want to thank you for coming in and joining us today and telling us more about the Dragonfly LDM Mark II.
Thanks so very much, Trevor, for your time. Greatly appreciate it. Look forward to having more conversations.
Global SMT and Packaging opens the windows of the world to bring you the latest news and technologies from Munich, from Bangalore, from Shanghai, from San Diego.